Hello students, welcome to my channel. First of all, a big thank you to you all to watch my previous video. In this video, we will continue with the solution of ISC 2024 examination specimen question paper, computer science, part 2, section B and section C. So part 2, section A we have discussed in the first video. In second video, in section B, we will discuss about 3 programs, and section C again 3 programs. Section B comprises of Java programming section, where you will get 3 programs, one from string, one from recursion, and one from 2D array. Let us see that. The first question given here is to find a number is even number or not. As you can see, this program is based on recursion. So basically in ISC question paper, number programs come with recursion or recursive process. There, one function out of others will be of recursive technique. And if the student do not apply recursive technique and use normal iteration in that, and the rest of the program all is correct, he or she will be given with the marks except that particular function or recursion marks that is being reserved for. So let us proceed with the question. As we can see here, class name evil contain 2 data members, num and bin. Num is storing the positive integer number, which will represent the decimal number, of course, and bin to store the equivalent binary number of num. Member methods are one default constructor. Default constructor's primary purpose in the program is to initialize all the data members with their default value, and hence default constructor do not have any parameter. Then the next function is accept num, then rec bin with the parameter x and void check. Finally, you have to write the main method and create an object of the class and call the functions accordingly. So let us see the solution to it. So you can see, as we have accept function to take the number from the user, we start with import statement followed by the class and the data member int num comma bin. Default constructor evil is initializing num and bin with 0. Now the student can write together num equal to bin equal to 0 in one line, or student can write in 2 different lines, num equal to 0, bin equal to 0. Both are correct. In the accept function, we are creating an object of the scanner class and taking the number through that object. Now here I have done one additional part, that is math.abs is converting the number to positive. In case if the user give a negative number, the student has 2 options. Either the student make an if statement to check the number is a positive number or not, otherwise it will be asked to re-enter or end the program there. Or what I have done, I've directly transferring that entire number through math.abs and converting it to positive number. Now let us see the rec bin, which is a recursive function here. Generally, a recursive function comes with a return type, but here the return type is void. This is because the number where the binary equivalent will be stored is the global data. So the function does not need any return type, but parameter int x will take the number which will go on in the recursive process to extract the number and convert to binary number. In recursive function, first we think of where to end the recursion, that we call as a base case. So here my base case is if x equals to 0, I'm doing only return. Only return does what? It ends the recursion and send the control back. Otherwise, we are extracting the digit x mod 2, and recursive function goes on with x divided by 2, and the binary number is formed bin into 10 plus r. Let us see the working of this recursive function. Here I have made the working. Suppose I am passing 10, the decimal number 10 to rec bin. What will happen? So x equals to 10. Inside the rec bin function, my base case is not encountered. So r equals to n 10 mod 2 equals to 0. And the recursive function calls itself again with the next number 10 by 2 equals to 5. In that function, I am doing 5 mod 2 equals to 1. And rec bin is called again with 5 by 2, that is 2. Then 2 mod 2 equals to 0. Rec bin 2 by 2 equals to 1. 1 mod 2 is 1 and rec bin 1 by 2 equals to 0. So when rec bin function is getting the value of x as 0, the base case encountered and the recursion stops here. As the recursion stops, backtracking begins. Now what happened in the backtracking? Rec bin 0 will return bin equals to 10 into 0 equals to 0, which will be returned to rec bin 1. Rec bin 1 is doing bin equals to 10 into 0 plus 1 equals to 1. This 1 is returned to rec bin 2. So rec bin 2 is using that value 1. 1 into 10 plus 0 becomes 10. Then 10 into 10 plus 1 becomes 101. Finally, 101 into 10 plus 0, 1010. And we know binary value of decimal 10 is 1010. So thus the recursive function is working perfectly. Let's proceed further. The void check function is calling rec bin, and now once the binary number done, we are extracting each digit from the binary number and adding it to count. Count is the value which will take care of how many ones are there in the binary number. Finally, if the number of ones come to even, the number is said to be even number, otherwise not. Now, the digit extraction process that I have used here is a for loop. The student can use equivalent while loop also. You can see here the while loop, which is just a replacement of the for loop. And we all know how to extract digits from here. Finally, in the main method, we create an object and call accept function and check function. The recursive function is not called in the main method. So if I run the program, we'll get the output positive number entered 12. It is an even number. I hope the students have understood the logic. Let's move to the next question. Composite array. Here a two-dimensional array to be created which will be filled with first m cross n composite number. And we all know composite number are non-prime numbers other than 1. So the class structure is as follows. Class name composite with data member, a 2D array, ARR, m and n, the rows and column. We have a parameterized constructor over here. Then int is composite int p, which will check the composite number, p as a composite number and return 1, otherwise return 0. Here it's not mentioned whether it can be a recursive process or non-recursive. So each student is free to use any logic. Void fill and display method. Let us move to the program code. So import statement followed by class composite with the data member, int ARR, double brackets, 2 brackets signifies rows and columns. That is, it is a 2D array. Int m and n. M represent the number of rows and n will represent number of columns. Now let us see the constructor. In the constructor, it is taking 2 parameters which will take on these 2 values and pass to m and n. Finally, we are declaring the array here. We are initializing memory allocation of the array here. Declaration is already done here. Int ARR semicolon. So here when we are reallocating the memory, we are not using the brackets again. Just ARR equal to new int within bracket m and n. Now keep in mind, we'll use this m and n throughout the program, not mm and n. Generally, few students make mistakes. They use the local variable. MM and NN are the local variable to the constructor and cannot be used anywhere else. Henceforth, we should use the global data M and N. Keep this in mind. Now, int is composite int p will check whether the p is a composite number, that is a non-prime number other than 1. I have used a different logic, but there are other logics also. What I have done, first I'm checking whether the number is 1 or a prime digit number. So if it is 1, 2, 3, 5, 7, the number is either 1 or a prime digit, then it is not a composite, it is returning 0. Else, if the number is divisible by any of the prime digit, it is a composite number. So if p mod 2 equals to 0, p mod 3 equals to 0, p mod 5 equals to 0, p mod 7 equals to 0, it is returning 1. Else, for any other number, they all are prime number, hence it is returning 0. Now you will see here I have used if else ladder. Excuse me, not if. Why if else? Because first if will remove all the prime digits from the checking, left over with all other numbers other than prime digit. There, if any number divisible by prime digit, it will no longer a prime number, rather it is a composite number. So I have used only if else to check a number is composite. There is alternate logic also. Let us see that one. So this is the alternate logic where we are checking how many factors are there for p. Now, if the factors come to 1 or 2, that means it is 1, the number is 1 or prime. So we are returning 0. And if the number of factors, that is c, is more than 2, it is a non-prime or composite number, it will return 1. So student may use any logic for prime check or composite check. Let's move further. Now the void fill, what I have done, I've called the composite number function, composite check function, and store all the numbers which are being passed to is composite and return 1 in the array column wise. The question is said to store the array column wise first m cross n composite number. So you can see here is a if. It is a little bit complex logic for some students might be. What I have done is I and j, here I represent row index, j represent column index, and a is the number that will start with for getting next composite number. So we are starting with 1. So if I less than m, that means it's the entire row is not reached for a particular column. Every time composite function is checked, the number a, and if it return 1, the a value, that the composite number is stored in ARR ij and I incremented. That means it will go to the next row. If the entire row completed, then it goes in the else block. What I'm doing, I'm moving to the next column and the row index again reinitialized to 0. And outside this if and else block, I'm incrementing a value to generate the next natural number, which will again check with is composite. The loop will continue until all the columns get filled. Now you can notice here that I have used a do while loop and not a while loop over here. There is alternate logic to this concept I have done here. If I use a nested loop, normally for a 2D array we use nested loop, so it will be little simple and easier for the students. Let us move to what I have done. First I have done the column loop for j equal to 0 to n, then the I loop 0 to m, but you see here I have not incremented. If the number is a composite number, I am storing it in the array and then incrementing I plus plus. Inside the row loop only I am incrementing a and the loop continues. So both other logic or any other logic can be used to fill the array. Let's move further. Display function is displaying the actual array, and in the main method we are taking row and column from the user and passing those two values in the object statement, creating object statement, and then calling fill and display. If we run this program, we'll get this output. I've taken row as 3 and column as 4. So you can see here, column wise 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25. All composite numbers are there in the array. Let's move to the next question. You can see here, this is a string question, and it is little bit, we can say, shifting of elements or changing the character to some other character here. What it is said here, all the vowels will be changed to the next vowel. So A will be changed to E, E will to I to O, O to U, and so on for capital letter as well as small letter. Input and output, sample input output is given. Class name encode with the data member word, length, and new word. Member method, default constructor, accept word, next vowel, display. And main method. So let us proceed to the program code now. So the class with the import statement, class, data members. In the default constructor, we are storing a word and new word with opening, closing double quotes. We call this as an empty string. In the accept word, we are storing the word and taking the length. Student might use here sc.next.trim to remove any additional extra spaces before or end of the string if somebody give by mistake. Now, the shifting of the character. Let's see the logic over here. The loop is running from 0 to less than length. Characters extracted from the word and stored in CH. Now, I have used a switch case over here. And you can see all the letters, vowels, all the vowels are changed to the next vowel. So A changed to E changed to I changed to O changed to U changed to A for capital letter as well as small letter. And default statement, it's doing nothing. But default we need to give. Otherwise, sometimes it may create error and the program will not run smoothly. Outside the switch, what I'm doing, in the new word variable, I'm concatenating the character. So if my character is a non-vowel, it is automatically added to the new word as it is. But if it is a vowel, it enters the switch, change to the next vowel and add up. This switch can again be written in another way using if-else. So there is the logic of this. We can use the same thing in if-else, but it will be a little lengthier than switch. You can see here. And finally, the display function and the main method. So if we run the program, so here then program asked for the word and I've given umbrella. So umbrella is changed to umbrella. Let's move to the next. Now we come to section C part. Section C part comprises of data structure where you will get one question on inheritance, one on stack or queue, and another one on tree and complexity. Earlier they were linked list, but this time linked list has been removed from the syllabus. First question you can see here as it is given a queue program. How a student can understand it is a queue program or a stack program? If it is a queue program, there will be two pointers. Here it's named as front and rear, or it can be named with any variable, begin, end, XYZ, anything. But there will be two pointers. One pointer to take care of the rear end of the queue, another pointer to the front end of the queue. Whereas if this question is of stack, there will be only one pointer named top. So we have the array, ELE, then the limit that will store the limit. Then we have front and rear, parameterized constructor, push val, again push val, pop val are two, just to name of the function, it can be any name. Push val basically it will insert one element to the queue, and pop_val will remove one element from the queue. Now you have to be careful what it is asked here. See here, in the constructor it said front and rear both should be initialized to 0. Normally for queue it begins with that front and rear both set at 0 and then we proceed further. But in some cases it might be both told to be at -1. There will be some different logic if that should be. Push function, if the queue get full, here it is given the message should be shelf is full. And the pop_val function remove the elements when it becomes empty. Here it is return -999.99. Again, we have to take care of what it is saying. And the display function. Now, as section C comprises of only 5 marks, you don't have to do the entire program over here. Whatever portion is being asked, only that part you have to write and nothing else. Though I have written the complete program here for your reference. And the next part of the question is name the entity described above and state its principle. So let us move further. So class self, double LE, the array, limit, then front and rear, then we have the constructor. And push_val, what I'm doing, see here, if rear equals to limit -1, that is it reaches the last index, will print self is full and return, only return over here, no return value. Otherwise, rear is being incremented and the value is being stored. Now here we have used post increment. Instead, we use pre-increment. Here is post increment. First, at element at LE rear, the data will be stored and then rear will increment it to the next index position. Now the pop function, in the pop_val, if front equal to rear, it means the queue becomes empty. Remember, at the beginning front and rear is at 0, queue is empty. The moment you add, rear shifted and it goes on shifting and moving far from the front. And when the element is being deleted, again front move nearer to the rear. And when both becomes at one index, again queue becomes empty. So here what I have done, if front equals to rear, queue becomes empty. Now here it is your responsibility. Again, front and rear need to be reset to 0. If you don't do this line, this queue will become inaccessible for anybody further, because rear being at the last, it will show every time queue is empty, full, and front is also at that position, it will say the queue is empty and you cannot access the rear queue again. That's why we need to reset it again to 0. And as the question said, we must return the value as it is asked in the question. So here it is -999.99. Otherwise, what I'm doing, otherwise return LE front ++. Again here, post increment. First, the element at front position will be eliminated from the queue, returned, and front will be incremented to the next index. Display function, though the student don't have to write the display function. In the exam paper, display if front equal to rear, queue is empty, otherwise the loop will run from front till rear -1 and elements are printed. Now the above entity is a queue and the principle implemented is first in, first out or FIFO. Let's move to the next question. Next question is an inheritance question. Here also 2 classes you can see, one is base class and another is child class. But the student has to write only the child class, not the base class, and not even the main method also required. But I have done both the classes for your reference. So what is there in the base class? Circle, radius and area data member, parameterized constructor, calc area, display. Now you have to keep it in mind. If the base class has a parameterized constructor, then in the child class, we'll also have a parameterized constructor, and you have to take care of the base class parameterized constructor invocation in the child class constructor. We'll see that in the code, what I have done. So base class portion, the student need not to write in the answer. So class circle, The data member for base class should be protected. If you do it as public, no problem. There will be no syntax error, but convention said, as it is inheritance, base class data member should be protected. So protected double area, radius and area. You see the parameterized constructor circle with double R, radius equals to R, area 0.0. Calc area is computing the area and display is displaying the area. So this is the base class. Let's move on to the child class now. Child class volume extends circle. Extends is the keyword which shows the inheritance is being established between the base class and the child class. And it is very, very important. If the student miss this statement, marks will be deducted from his or her answer paper. Then we have the data member in the child class, height and volume. The volume class parameters constructor, you all notice. Here we have two parameters. One is double R and double H. This double R is for the base class data member radius, whereas double H is for the data member height. Now what I have done, super and pass R. This super is the keyword which will invoke the base class constructor and initialize the data member through that constructor. Now you all know that constructor cannot be called explicitly. So super here helps to invoke the base class constructor through child class constructor. And again, there is a convention in a constructor or in a child class method. Priority goes to the base class. So first base class need to be referred, then the child class member will be invoked or referred. So first super R is initializing the data member radius, then height is initialized with H, volume equals to 0.0. Now instead of super, if I write radius equals to R, that also no problem, it will initialize. But the problem there occur is as base class has a constructor and it has not been invoked, it might be ambiguous. Now, in the double calculate function, I'm calling calc area. It will calculate the area. Now, when we get the area, volume will become easier. Area into height. Finally, in the display function, you see I've done super.display. Now, this super.display will call the base class construct. Display function. And finally, we are printing the volume. Now, you notice here, parent class also have display, child class also have display. That means both the classes have same function with same name and same signature. And this is called as function overriding. Function overriding is actually a situation where child class overrides the base class method. Like if you create an object of child class and anytime you go on calling display function, you will be called with the child class display function and not the base class. Base class display function will become suppressed by the child class. This is known as function overriding. And it is resolved with the help of super keyword in the child class. So super will invoke base class display function inside the child class. I hope you all have understood the concept. Let's move on to the next question. Next, in the last question, in section C and in an entire question paper, we have one complexity question. This has been added from this session only. With the help of an example, briefly explain constant factor in the time complexity and given a binary tree, name the external node of right subtree, state the size and depth of the tree and write the post-order traversal of the above tree. Let us see the answers one by one. First question. So, what is constant or constant factor? When our algorithm is not dependent on the input size, it is said to have constant time complexity or order big O1. This means the runtime will always be same regardless of input size. An example you can see, finding an array index or push and pop operation in a stack where only one operation of add or delete takes place into or from the stack. So these all have complexity 1. Also, the constant factor play a minimal role in the computation of complexity and hence it is dropped. But when two algorithms have same complexity and the constant factor decides which is faster, let us see an example. Suppose algo 1 requires n square time and algo 2 requires 10 into n square plus n time. So both the algo have the complexity big O n square, but algo 1 will become faster than algo 2 because there is a constant factor 10 in the algo 2 which is being multiplied to n square. Now the next question, let us see the tree. The tree is given here where A is the root and its left subtree, BD, right subtree, FGHI. Here the question asked, see, E and H are the leaf nodes in the right subtree of A, where A is the right node. So this is the right subtree. Then what is the size of the tree? The entire tree, the total number of nodes. Here it comes counting 7. Depth. Now how depth is computed? It computed with the longest path, the total number of nodes in the longest path, or in other words, level plus 1. If the level starts from 0. So if I assume root A at level 0, the next level 1, 2, 3. So total depth of this tree is 3 plus 1, that is 4. Finally, post-order traversal. Now how to get the post-order traversal? See, we'll start with the leaf node. At E, the traversal, post-order traversal is E, H, post-order traversal H. At D, the post-order traversal is D, where at G, post-order traversal is E, H, G. Then at B, it is DB. At F, it is E, H, G, F. And at last, at the root node A, the post-order traversal is D, B, E, H, G, F, A. Now, post-order traversal means left node, right node, then the root node. Left, right, root. So hence the final answer is D, B, E, H, G, F, A. That's all from my end. Thank you and all the best for your examination. But my suggestion is you need to practice sometimes with small codes or other workings, may it be Boolean algebra, logic gates, Karnaugh map, entire question paper. Try some portions and keep it in your brain active. More you keep it in your brain active, it will be retained there and it will be easier for you to score full marks. In computer, scoring 100 of 100 is not very tough and everybody can get it if he or she desired to do that. Thank you. Good night.